Okay, guys, welcome. Today we're going to talk about the law of sines and the law of cosines. Okay, so what we're going to look to do in this section, we're going to talk about how to find angles or side lengths for a specific triangle using either the law of sines or cosines, and then we'll finish up by sort of going over some ways of when to use which one. Okay, so the law of sines says that if we have side lengths, if we have side lengths indicated by the lowercase letters A, B, and C, and the angles are indicated by the capital letters A, B, and C, and angle A is opposite side A, angle B is opposite side B, angle C is opposite side C, then we have this relationship between these six quantities. Sine of A over A is the same as sine of B over B is the same as sine of C over C. Okay? So let's see if we can use this to our advantage here. Now, in this triangle, we have that, let's start with one that we know, right? So we have that this angle opposite to it is 4, right? And this we'll call angle A, and this will be side A, so lowercase a. Now this is side B, and across from it we have angle 63. And then finally, this would be, let me use a different color. This, of course, is angle C, and across from it we have side C. All right, so there we actually don't know either one of them. But by the law of sines, we know that sine of A over little a is sine of B over little b, which is sine C over little c. Now let's fill in what we know. We know that A is 76 degrees, and we know that side A is 4. Okay. We also know that sine of B is sine of 63 degrees over side B. And actually, for side C, we don't know anything just yet. Okay, so with this, you're always going to start with one where you know 3 out of 4, right? So in sine C over C, we don't know either one of those. So we're going to start by looking at these two. Now to solve for B here, you have two fractions that are equal to each other. So you're going to cross multiply. So we can say that B times sine of 76 degrees is equal to 4 times sine of 63 degrees. So of course, to get B by itself, we would say that B is equal to 4 times sine of 63 degrees over sine of 76 degrees. So we can find that B, by using our calculator, would be 4 times sine of 63 divided by sine of 76. And we'll get that B is roughly equal to 3.6731, we'll say. All right, so that's our side length B here. Okay. Now, let's go back to the issue of C. So we found B. We found that this was equal to 3.6731, right? 36731. Yep. Okay. Now, first of all, can we get angle C? Well, of course we can, because we know that the three angles inside of a triangle better add to 180, right? So if I want to find C, that would be 180 minus 63 minus 76. All right, so if we do that, 180 minus 63 minus 76, we get that C is 41 degrees. All right, so this is 41 degrees. Now, we can't use Pythagorean theorem to get C because we don't have a right triangle, all right? But we do know part of this now. So now we can use the sine of 76 over 4 from before, And we can say that's equal to sine C because we now know what C is. Sine of C is sine of 41 degrees over C. And we find C the same way that we found B. We cross multiply. So if we cross multiply here, we get that 4 times sine of 41 degrees is equal to C times sine of 76 degrees. And then if we divide, we get that C is equal to 4 sine of 41 degrees over sine of 76 degrees. All right, so then we let the calculator do the work again for this. We've got 4 times sine of 41, and we divide that by sine of 76. And we get that C is roughly equal to 2.7 here. All right, so that's how we can use the law of sines to figure out our remaining two sides and our remaining angle, okay? Okay, now we want to find all the angles in a triangle that has one side length 8, one side length 5, and a 30-degree angle opposite the side of length 5. Okay, so if we draw this out, all right, we have one length of 8, one length of 5, another one that we don't know, and the 30-degree angle is opposite the side of length 5. So we have a 30-degree angle here. All right, so for example, I could call this side C and this angle C. I could call this side B and this angle B. And I could call this angle A and this side A. So if we set up the law of sines again, we know that sine of 30 over 5 is equal to sine of B over 8. And this is equal to sine C over C. All right, so as we did before, we're going to start with the one where we know 3 out of 4. So we're going to start with this one. So if we cross multiply, we're going to get that 8 times sine 30 is equal to 5 times sine B. Here we can use the fact that sine of 30 is 1/2. And then so we're going to end up with a 4 over 5 is equal to sine of B. So now use the inverse sign. You could say the inverse sine of 4 over 5 would give me B. So if we let the calculator do this, 4 over 5, we're going to get that our angle B is roughly equal to 53.13 degrees. So this is 53.13 degrees. All right, so just like in the last one, we can now find angle C, and that's going to be 180 minus these other two, so minus 30 and minus 53.13. So if we do that, we're going to find that C is equal to 96.87 degrees. All right, so that's this angle, 96.87 degrees. So now finally, to get angle C, we can use this one and this one. And again, we know now that sine of C is sine of 96.7. So we have sine 30 over 5 is equal to sine 96.87 over side C. So we can cross multiply again and we'll get C times 1/2, because that's sine of 30, is 5 times sine 96.87. And then just divide by 2, multiply by 2. And we'll find that our C here, so I need to do 2 times 5 times sine of 96.87. And we'll get that our C is roughly equal to 9.93. All right, so that allows us to get that remaining side of that triangle. Okay. All right, one more example of the law of sines. We want to find all angles in a triangle that has one side of length 5, one of length 7, and then a 100-degree angle opposite length 7. So we have 5, 7, and 100 degrees is here. All right, so again, same idea. I'm going to call this angle A, side A. We'll call this angle B, side B. And we'll call this angle C, side C. So again, we have sine of 100 over 7 is equal to sine of B over 5, and that's equal to sine of C over sine C. So first, again, we'll focus on these two, and we'll find that 5 times sine of 100, once we cross multiply, is 7 times sine of B. So then we can divide each side by 7, and we'll get that B is whatever 5 over 7 times sine of 100 is. Wait a second, what am I missing here? Sine of B, sorry. All right, so now I want to take the inverse sine of both sides, and we get that B is inverse sine 5 over 7 times sine of 100. And of course, there's a little bit of a problem, right? And the problem is that 100 is not going to be in the domain of arc sine, but in this case, it's okay because when we multiply it by 5 over 7, it should be able to bring it into where we would need it, okay? So if I multiply 5 over 7 times sine of 100, we're going to get that we're taking the inverse sine, something like 0.703434. And if we type this in, let's see, so it's inverse sine 0.703434. We're going to get that B is roughly equal to 44.7032 degrees. All right, so just as before, we know that angle C is 180 minus 100 minus 44.7032. 100 minus 44.7032. And we get that C is roughly equal to 35.3 degrees, roughly. Okay, so last but not least, similar as before, we can say that sine of 100 over 7 is sine of C, which is 35.3 over side C. So then we can cross multiply and we get that sine, let's see, did I do everything right? Oh no, that's fine. Okay, so if I now take C times sine of 100, we get 7 times sine of 35.3. So I can divide both sides by 100. And that will give me C. So if I do 7 times sine of 35.3 and divide that by sine of 100, I'm going to get that my C is roughly equal to 4.107. All right, so that's filling in all of our missing stuff for that triangle. Okay. Now the next law that we'll talk about is the law of cosines. Okay. Now the law of cosines looks a lot like the Pythagorean theorem, except we have this extra 2ab cosine C. Okay. Now the idea here is that the angle C corresponds to the side opposite with length C. Now, if you think about it, usually C is your hypotenuse. And if your hypotenuse, that means that the angle across from it is 90 degrees. And of course, the cosine of 90 degrees is 0. So when you have that your angle is a right angle, you get the Pythagorean theorem exactly. all right? But you can modify this slightly to work for any type of triangle, as long as you make your C, the angle across from it is the angle that you use in this formula, okay? So now here we want to find all three angles. So if I want to, for example, find angle A, then I need to make sure that my A is by itself. So I would need A squared is equal to B squared plus C squared, and then it's minus 2BC, the other two sides, and then times the cosine of angle A, right? Because again, remember, the angle C is opposite the side with length C, right? So now if I compute this, all right, my A, or my side across from the angle A, is 5. So I need 5 squared is equal to B squared. So the side across from angle B is 7. The side across from angle C is 6. I need to subtract 2 times B, which is 7, times C, which is 6. And this is all going to help me find the cosine of A. Okay, well, this is 25 is 49 plus 36. And then I'm going to get a minus, let's see, is 6 times 7 is a 42, and then times 2 is a minus 84 cosine of A. So now I want to subtract whatever the sum is. So 49 plus 36 would be an 85. So I'm going to subtract 85 from both sides. I'm going to get minus 60 is minus 84 cosine of A. So when I divide, I'm going to get 60 over 84 is cosine of A. And then when I take the inverse cosine of both sides, I'm going to get the inverse cosine of 60 over 84 is my angle A. So A is the inverse cosine 60 over 84. And that will give me roughly 44.42 degrees. All right, so we have our first angle, angle A, 44.42 degrees. Okay, now we can do something similar for angle C or angle B, it doesn't matter. Let's do angle B, I guess. Okay, well, I want to have then B by itself, so I have B squared is A squared plus C squared minus 2AC cosine of B. All right, now if I plug in here, my B side is 7, my A side is 5, and my C squared is 6, and then 2 times 5 times 6 times cosine of B. So I get 49 is equal to 25 plus 36 minus, and let's see, I'll get a 60 cosine B. So now if I subtract this from both sides, I need to subtract a 61. So I'm going to get a negative 12, right? And then if I set that equal to negative 60 cosine B, divide by negative 60, I get 12 over 60 is cosine B. So finally, B is the inverse cosine of 12 over 60. So if I type this into the calculator, inverse cosine 12 over 60, I'm going to get that angle B is roughly 78.46 degrees. All right. Now you could do the same thing for angle C, but we can also use the fact that angle C again is 180 minus 44.42 minus 78.46. Right? So if we find this, 180 minus 44.42 minus 78.46, we get that C is roughly 57.12 degrees. All right, and you should get something similar if you used the same methods that we used to get angle A and B. All right, but that's the law of cosines. Okay, let's do another example of the law of cosines. Okay, so we have a triangle has sides of length 5 and 3 and a 40-degree angle between those two sides. So we have this 40-degree angle here, right? Now we want to find the length of the third side here, okay? So now, which rule should we use here, right? So we either know that we could get, if this is side C, then if I used C squared is A squared plus B squared minus 2AB cosine of angle C, I have everything that I need on this side. So I will be able to get C in this case. So C squared is equal to A, which I can say is 3 squared plus 5 squared is 2 times 3 times 5. And the angle opposite C is the 40 degrees. So now I can say that C squared is 9 plus 25. And this is minus a 30 times cosine 40. So if we find this is a 34 minus 30 cosine 40. So if we find that, 34 minus 30 times cosine of 40, we get that C squared is roughly 11.02. So then if we square root that, we get that C is roughly 3.32. All right, so that would be the C side in this case. Okay. Now, of course, when to use each law, you would use the law of cosines in, like we did in the first example where you knew the length of all three sides, or in the previous example, if you know the length of two sides and then the angle specifically between them. All right. And basically, if it's not one of these two cases, you would use the law of sines. You would use the law of sines when you know two angles and the length of one side, or you would use it when you have the length of two sides of a triangle and a different angle that's not the angle between them. Okay, so we'll do two more examples to showcase this, and then we will wrap this video up. Okay, so in example 6, we have that a surveyor needs to measure the distance to a landmark L on the inaccessible side of a large canyon. All right, so observation posts D and E on the accessible side of the canyon are separated by 563 meters. So let's maybe start drawing this out. So we have L here, and this is on the inaccessible side. And then we have D and E on the other side are separated by 563 meters. Okay, now from observation post D, the surveyor uses a surveying instrument to find the angle LDE. So that's this angle here is 84 degrees. Of course, it's not drawn to scale. From observation post E, surveyor finds that angle LED, so that would be this angle here, would be 87 degrees. All right, so now, of course, the question becomes, we want to find these two other missing sides, right? Now, since we have two angles and a side, this means we want to use the law of sines. Right? Now, of course, we don't have this angle right now, but we can get it, right? Because this angle would be 180 degrees minus 84 minus 87. So if we do that, 180 minus 84 minus 87, we're going to get this angle is 9 degrees. Okay, so now we can set up the law of sines. We can say that if this is side D and this is side E, then we know that sine of 9 over 563 is equal to sine of 84 over side D, and that equals sine of 87 over side E. So just like before, we'll start with these, since we know 3 out of 4. You could just as easily use the other one. But if we cross multiply, we'll find that D times sine of 9 is equal to 563 times sine of 84, So then D is 563 times sine of 84 over sine of 9. So if you do that, 563 times sine of 84, and we divide that by sine of 9, we get that this distance D is 3579.24 roughly. Okay, so we have, this is roughly 3579.24. And of course, to get E, we could use something similar, only now we're going to use this one and this one. So if we cross multiply, we'll find that E times sine 9 is equal to 563 times sine 87. So then side E is 563 times sine of 87 over sine of 9. So if we multiply and we divide by sine 9, we're going to find that side E is roughly 3594.02. And I think this was all in meters, right? Yeah, so both of these should be meters. And those are the other two sides that we needed. That was part A and part B. All right, so in that case, we wanted to use the law of sines because we knew two angles and a side. Okay, last example for this video, we're going to look at the radar at an air traffic control tower shows the distance to an incoming plane is 5 miles. Okay, so we have the air traffic control tower, and there's a plane, and we know that this distance is 5 miles. Okay, now the distance to an outgoing airplane is 10 miles. All right, so we have, this is 10 miles. Okay, and the angle incoming airplane to the tower to the outgoing airplane is 42 degrees. We want to know how far apart are the two planes. So we want to know this length here. All right, well now in this case, we have two sides and the angle between them. So this is the law of cosines. So we have two sides and the angle between them. So again, the setup here is that I can use x squared because that's the angle I know, and I can say that that's 5 squared plus 10 squared minus 2 times my two sides, 5 times 10, times the cosine of 42. So then x squared is 25 plus 100, and let's see, then I'll get a minus 100 cosine of 42. So I get that x squared is 125 minus 100 cosine 42. So if I do 125 minus 100 times cosine of 42, I get that x squared is 50.69 roughly, and this is in miles, right? And then if I square root 50.69, I'm going to get that x is roughly 7.12 miles. All right, so by this, we could say that the planes are roughly 7.12 miles apart. All right, so that wraps up this video on the law of sines and the law of cosines. I hope you enjoyed, and I will see you next time.